issues out there, as we call environmental. And some of them are a combination of environmental, safety, engineering issues. They kind of amalgamate into a single set of problems that give you a big headache. And in case of residential, I usually try to, in my line of work, I usually try to just negotiate them through it, try to get them to do it themselves. It just doesn't justify a high-paid consultant to take care of most residential issues. That's not to say that it doesn't come up sometimes.
Because people would tend to do in those kinds of things, whether it's asbestos-related issues, say in a home, and we'll start with those. You really, if you want to remodel, for example, Joe, we're going to remodel our house, or I want to remove it, I want to put a new place in, I want to haul a manufactured home away. Those kinds of things are out there, and it's that type of area that we don't know what to do. That's where we still need to have some help on this, correct? Now, you don't do testing, for example, do you? I mean, there's labs that do that, but you can just tell me how that process works a little bit.
I owned a couple of labs in the past.
Yeah.
And basically, a lab is just, it's not an intelligence. It's a methodological entity. So it doesn't really tell you what to do with your results.
Right.
Now, there might be knowledgeable people in the lab, and certainly the lab is full of knowledgeable folks. But an environmental laboratory generally isn't in the business of telling you what to do now that you've got this or got that. Now, some do have a lot of knowledge in this or that, particularly in drinking water, some other field. But when you're talking about environmental, you can start off understanding it by first looking at how the regulatory body, primary regulatory body that you will encounter, divides its departments.
What they're going to do, okay.
They have soil, they have groundwater in terms of pathways, they have air, they have hazardous waste, solid waste, and all those categories, stormwater, groundwater, all those categories are actually really separate departments. Underground storage tanks, they all fall into different categories, which you can just look it up on the DEQ's website, and you can kind of get an idea how environmental modeling is done. Now, after that's said, when you get down to the particulars of, let's say you encounter, in one case at a site, they were noticing in the parking lot that there was a sinkhole.
Okay.
Where did the sinkhole come from? Let's get an excavator out there, dig down into the sinkhole, and they find some old tank that never showed up on any Sanborn records or anything like that. Just out of nowhere, it was there. Nobody knew. It went back to the 20s or 30s, and it wasn't identified in any maps. And they find it's been leaking, okay, and it's been getting into groundwater for
long time,
80 years or something.
So you have a leaky tank half full. You got water, groundwater comes up, spills it up, it goes down again. Each year it comes back up and continues to do that.
Exactly.
So now it's gone all over the place.
All over the place.
Or we think it goes all over the place.
Right.
But you say maybe it really doesn't.
Well, what you do then is these days, it used to be that whenever you encountered something like this, you needed to get down there and dig it all out and take it to a facility. An approved landfill or some sort of containment area, and you had to take all the groundwater out, and you had to treat the groundwater and so on.
And the soil that you brought expensive. Okay,
very expensive. After I noticed it's always been in place with the EPA since the 70s, but after the heating oil tank regulation, leaking heating oil tanks now private are regulated if they are leaking. Okay, if there's any kind of release of hazardous materials, which in this case is number 2 or number 4 diesel, that then becomes a DEQ issue. And so consequently, they had to develop a licensing program, and this occurred in the early 90s, and they needed another approach other than removing everything.
Just take everything, pull it out there, dump it in trucks, haul it to the landfills. There's a better solution.
There would be so many of those to do and to take care of.
All right, and so what they did was they implemented something that's always really it's been in place for a longer time, called the risk-based approach. And the risk-based approach basically gets you to identify really what the questions it's asking is: yes, there is hazardous materials in there. There's there's hazardous waste,
Lots of stuff.
or oil, or some regulated waste. But who cares? In other words, who does it affect? You need to quantify it, and so you have to develop a methodology for doing that.
And so a spill like that, or if you have that contamination, it's different, say, if it's in a parking lot than it is in a residential area, or where it might go, or if you're in an urban area versus a rural area, if you're by a stream, if you're not by a stream. Is that what you're talking about, kind of
True.
thing like this?
They call it, now let just use some nice, heady language.
Yeah.
They call the persons that are affected, those are the receptors.
Okay.
Those are people that could be, whether they be an excavator worker, excavation worker,
Okay.
or a construction worker. Those are two different things with two different types of exposure,
Right.
whether they're residential, urban residential, or commercial, whether they're, where are they in relationship to groundwater, all those kinds of issues. What kind of media they like to use. Media, which means simply, in most cases, is simply air, soils, or groundwater.
Yep.
And so those are and stormwater for the ecological side. So the media, the receptors, the pathways, who does it affect? Is it route of entry into your body? How does it get to you? Do you eat it, ingest it? Is it vapor?
So you've found ways to do this in a more efficient way. You say it doesn't affect, or how it affects people. Do you see a lot of this? Have you done a lot of environmental cleanup in Jackson, Josephine counties around here? Properties?
Oh, yes.
What types have you seen? Just tell us, what have you seen? What have you actually done in terms of when you get to these places?
Well, I've seen, I've held all the licenses available in the state. I don't hold them all because they all come with a cost as far as keeping licenses. And you just have to make a decision. Do I really need the underground storage tank issue on the commercial side, for example, service stations, has greatly decreased. Now, there's still a significant number of heating oil tanks out there. And then you come up with the one I just described to you, $60,000 cost to the owner to find this sinkhole and find this tank and then have to do a risk-based cleanup. So I'd say that I've done all of them. The residential, of course, is a very small proportion
part of that, sure.
Yeah.
But it certainly is. When it happens, it seriously hurts a residential. It can be a lot of money if you're not careful.
Okay, beyond Jack, beyond just the ground contamination by tanks, oil tanks or gas tanks, what other contamination do you see in ground? I would think that would sewage, septic tanks. Not that you would involve with those, but I would think those would be a hazard at some point if they collapse or they've abandoned. And those types of things. Is that what else would be out there?
Is radon in our area?
Well, there is radon, but not very much of it here. This is not. That's more of it. You see that, like, for example, someplace like West Virginia. It's not that you don't have radon here. Whenever you're doing an assessment, environmental assessment, which is something I commonly do. I think I've done 1,600 of them.
Oh, wow.
Last 20 years or something. I find radon has never been
an issue here. What about commercial properties? I can see, lots of trucks. We got truckers. We got lots of activity around. Do you see if someone's going to buy a commercial piece of property, they want it cleaned up. It's got to be cleaned up for environmental purposes. Do you see that around as well, too? And what kind of pollution, not the right word. What type of stuff is there? Contaminants do you find generally?
Most of the time, I'd say 98% of the time, I'm putting a number arbitrarily,
right.
but it's petroleum based. But what you're concerned about is when petroleum has a lot of fractions to it. It has polyaromatic hydrocarbons, nucleic hydrocarbons. It has.
That's a good word.
It has.
I've never heard that one there before, Jack. That's a good one. Okay.
Call them PAHs.
Okay, I like that. Yeah.
And you have all kinds of constituents, semi-volatiles and volatile constituents that come out of gasolines, diesels, and different fractions, and those break down and separate out, and they get into the soils, into the groundwater, as chemical and separation occurs, and even physical gravimetric separation occurs. So you have these basic. When you're doing a cleanup, you're trying to give the DEQ information, not just the DEQ. For example, when I'm doing sediment analysis on the coast, because I consult a lot of ports, when I do that, I'm really referring to sediment evaluation framework supplied by the U.S. Army Corps of Engineers.
Okay.
They're the regulators there that I deal with.
Okay, so you want,
And so you have different regulators depending on the different
Sure.
Scenarios that you're dealing with. But most of the time, when it comes to anything that can be related to underground storage tanks or cleanups, you're going to be dealing with the DEQ.
With DEQ, and everyone knows, so people know about DEQ and all the issues and things with them. You see, do you ever see, Joe, you go into a lot of those meetings with the city and the county still. Does environmental cleanup, do they ever address these kinds of things or pollutions that's going on with around us that someone like Jack would ever be involved with, or do they even talk about this stuff in government?
Most of what I see is what is coming and is in the works, and the ordinances I think are already in place, and the guidelines are already in place to prevent a lot of that from happening. But most of that is our projects that are in the works are being vetted through the planning commissions.
And there's a lot of them.
There's a lot of them, yeah.
But you're really busy. I mean, Jack, you have a lot of you have a lot of things going on.
I do. Yes.
So there's that. I mean, there's that much remediation, I guess, that's taking place within that whole realm of environmental cleanup across this whole broad spectrum. Now we got a break coming up here in a couple of minutes, but I know another thing that you're involved with that again we don't think sometimes a lot of is what we use in manufacturing. And think about the hundreds of small manufacturers, Joe, that are in the valley, and large ones too. Amy's Kitchen's a big place. What about the cannabis part? Because they're manufacturing and using lots of chemicals and things, aren't they? I mean, that's the way I understand this thing. So those things, can they get into the grounds too around as people do this kind of thing, Jack? Or just kind of what's your thought on manufacturing and what's going on with that in the valley, this whole big spectrum that we have now?
Well, manufacturing is a big word, and there are a lot of different products.
Right.
But they do narrow down to process and materials. I don't care who you're talking about, what they're doing, what they're making.
Processes and
materials.
How you do it and what you use to do it with,
And what you use to do it with. There's a strong trend in industry to get to be environmentally friendly. I have plants that I have consulted for decades, large plants, that, for example, in their coating processes have gone away from the volatile kinds of
toxic chemicals.
Coatings that are
corrosive,
have a great deal of emissions. Types of greenhouse emissions. So, and going to more water-based type, oven cured, sometimes IR cured or whatever, UV cured. I mean, types of
kind of like going from lead-based paint to water-based paint, kind of thing like that. We've got a break coming up here, so we've got a lot more to talk with you about here, Jack. That's for sure. It's a fascinating topic, environmental regulations, and we're cleaning it up. Look how far we've come when you think about that in our environment. Here's just here in the Rogue Valley the last few years. Anyway, we're talking with Jack Aiken from EMC Engineer Scientist. We're coming back. The Real Estate Show continues right after this. The Real Estate Show continues here on KMED. December the 2nd is our date. Pete Belcaster and Joe Brett, the real estate guys, with you here in the house today at KMED. Hope you're going to make a good weekend out of it as we count down the days now to Christmas and New Year's. Some terrific shows ahead as well. We got an interior designer coming actually in the next few weeks or something.
Boy, could I use some help with that? You've been to my house.
That's good. I never thought of that, but no, that would be good.
I'll bring my notepad that day.
Yeah, that would look beautiful. It's around there.
It could only go one way.
And today here on the show, we're talking with Jack Aiken, who's the owner as an environmental scientist from EMC Engineer Scientists here in the Rogue Valley. And so far, we've learned some good things here about pollution and cleanups and the regulations and rules and stuff. And what's good to hear from Jack is that he thinks he got a handle on a lot of it, that's actually you can do these things and clean them up without the horrific expenses. Because how many times do you see business people or investors saying, I'm not going to touch that property, it's got an environmental issue, right? I mean, you see it all the time.
Deal breaker in a big,
but what we're
like
hearing Jack say, and you said, Jack, is you can remedy these. There are remedies, and it doesn't take the millions of dollars by doing it, by having someone like you come out and look at it and work with it, right?
I've never seen it. I've always seen good news out of taking a careful, strategic approach to solving these problems. Every one of them is solvable. So, I mean, I realize there's some that are worse than others, but in our valley here, I've never seen anything that can't be solved.
And look how look how far we've come. Seriously,
I was just going to say, going forward, your job has got to be easier because we've learned from the mistakes and from the bad practices and what their effects can be, and we apply those as we go forward and build and develop.
Sure, there's quite a nice base of knowledge now.
Well, before that last break, we were talking about manufacturing here in the valley, and we've been talking about things that go into the ground, pollute the ground, but there's also a great portion of this that goes into the air. And if you're working in around those environments, well, I think it was your wife went through that, Joe, Margaret Ann did, about working in a place that had chemicals that were so strong that she got very ill over that. So it's those kind of things that are out there too that actually have an environmental solution, according to Jack, right?
Of course, yes.
Right in there. Go ahead.
So if you're talking about the manufacturing community, we have to all remember that is probably the most complex environmental model out there. The regulations are the highest, as you'll find.
Lots of regulations in manufacturing.
The world. So when you look at the categories that you generally look at hazardous waste, and hazardous waste is when if you're done with a material, whether it be liquid or solid, and you're going to throw it away. At that point, you have to evaluate it and see what you got to do with it. And it's usually a result of a process, right? And
you made something.
You did something.
And
manufacturers
do those things. Yeah.
You added value to something. You took something and you added value to it, and that's manufacturing. So the process of evaluating that is something that we're all supposed to try to learn how to do in all these fields. But manufacturing, even though you make everything from widgets to buggy whips, whatever you make, you're still it's gonna narrow down to that processed materials. So if you're dealing with hazardous waste, you're going to deal with wastewater that comes from your facility. You
get wastewater out of the hazardous waste that you're using in the manufacturing process. You don't know to put that into the Medford storm drain or the Medford. I don't think that would be a very good idea.
No, probably not. And or not to the storm drain, and a lot of times not even to the wastewater treatment plant, which is where it goes if you've got city water and city wastewater, sewer. And you've also got air, so you're going to deal with what kind of emissions are coming from your particular operations. And you look at, then you're dealing, you described earlier, you're also dealing with the health and safety issue.
Right.
Health and safety issue in terms of regulation is actually regulated by OSHA.
Oh.
And so, but nevertheless, OSHA, they do heavily come together. If you're in, let's say, an electronics plant and you are soldering and you're doing soldering on circuit boards, one of my clients, several of my clients had that process. And basically, you're cleaning your circuit boards and wiping off your soldering tool. The sponge itself, if it's lead-based,
you're going to get all sorts of fumes.
It's going to get lead on the sponge. You're going to go up to wash it off in your faucet. Now you're washing lead
down into the drain.
Now the fact is that many solders today now have gotten rid of lead. So this is an idea of going to the process and going to the materials, changing the materials. Suddenly you've gotten rid of the issue from a safety, that is exposure to the employee to lead, as well as the environmental issue of putting a lot of lead into the ground.
And nobody wants to work in that kind of environment. You also said you found a company that was using a lot of toxic chemicals to clean some equipment, and you were able to change that. I mean, I can imagine. You imagine vats and vats and gallons and gallons of this, toxic stuff that you're dealing with going into the air. But you found a solution to that. Tell us about that. That was a pretty interesting thing.
Okay, well, it's a company that had thousands of feet of overhead conveyor, and they used oil-tempered spring steel hooks to hook and hold parts up while it went through a whole coating process. Okay, and the hooks themselves
would get sprayed as they went through the process,
and they would be the overspray then would have to be dealt with. So it's all built up and hard on these hooks, so that at night shift, the maintenance would go ahead and take them off the conveyor, run the conveyor through, take them all off, put them on racks, dip them into large vats of methylene chloride,
Methylene chloride.
A methylene chloride is the active solution that you'll find in your furniture strippers, for example. You buy a stripper at the store. So it's carcinogenic. It's chlorinated material. It's strong stuff, and it's dangerous in many ways, both chronically, long-term, or acutely.
And these guys are using it all the time to do this cleaning process thing out of the air. Okay.
So, and it's costing them a lot of money. There's a lot of chemicals involved. I mean, a lot of cost.
A lot of money, yes, absolutely.
On top of that, you're creating a lot of hazardous waste. So you're entering into a realm, a zone of regulation as what they call a large quantity generator. And that means you're generating, in this case, you're generating a certain amount of gallons of hazardous waste per month. Yeah. And you find yourself and that takes a lot of management, cost, so on.
So you found a solution to this.
What we did was we said, okay, look, why don't you use a heat cleaning oven? It's already in solid form. Take the hooks and bring them through a heat cleaning oven, which will turn it into ash. You just bang it, the ash falls off. It's very little of it. Take it and put it back on the rack.
And this local company, you said, got their investment back
21 days.
Isn't that amazing?
Wow.
So think about that. Yeah. That's just incredible.
So it means every 21 days thereafter now, for it's been now a decade and a half, every 21 days, they make that money that they would have had to pay previously. And the unseen, if you will, cost of employees being exposed. Right. If you have a respirator program, respirator programs are not good in the sense that, you always have to manage whether or not they're properly using it. People will expose themselves to chemicals that they wouldn't normally, thinking they're safe. And so it's, you try to get away from, I always try to get folks away from respirators if I can.
And that's good advice, isn't that?
How important is that work, though? Save the company money. Improve their employees' health conditions and environmental conditions at the workplace. There's a win-win in every aspect of that for everyone involved.
It's good because you find out that this is funny. You see folks that what they call environmentalists, and you see folks that are anti-environmentalists. You see people called tree huggers. You see all kinds of people, a whole spectrum of folks out there. Okay, but in reality, in terms of what I found when you take careful. And the engineering side of me tends to do that for me, kind of sterilizes my views. But when I look at an operation and I look through the paradigm of the glasses, the environmental glasses, a lot of times I find better, more elegant solutions out there. So it is definitely a help to helping in that area.
And Joe, as you talk about helping for individuals working in those environments, my concern is that we're manufacturing more cannabis now. Is that and they're using chemicals? Is that regulated in any way? Does OSHA come around to the cannabis farms if you're manufacturing and doing that with chemicals, and you can have explosions, etc.
Especially in
lots of oils, lots of things,
like that.
And a lot of things can go wrong, as what we found out. So anyway, it's a fascinating topic, and we got one more segment to go. And Jack's going to share with us his experience at the port of Brookings after the tsunami. I mean, engineering solutions are just amazing as you go through this, and we'll talk about that when we come back after this. Real Estate Show continues here on KMED. Don't you dare go away. We're coming right back. Real Estate Show continues here on KMED. December the 2nd is our date. Hope you're going to go out and have a good weekend. Pete Belcastro, Joe Brett here with you today. Next week, we'll have a John L. Scott Market Watch show as we hit into December. 2 weeks from today, the Rogue Valley Association of Realtors will be back, and we'll have a program with them. Mortgage interest rates along the way, interior design. Have some great shows online. Don't forget you can check out any of those past shows at realestateshowOregon.com. Permitting. That's one of my favorite shows. Learn more about permits and when you need to have a permit and don't need to have a permit and things like that. When did you go back? Jackson County goes back to 1975 with those permits. But boy, the city of Medford, they go back like to the 30s. It's really interesting to go back and look at what's out there when you're looking at purchasing a property. Today on the show, Jack Aiken, who's the owner and is an environmental scientist from EMC Scientist Engineers here in the Rogue Valley. And we've been talking about, environmental issues that are out there. And we learned a lot again. We got good listeners of our, our radio listeners are pretty good savvy when it comes to real estate. And here, these are issues that many times we just don't even think about, but are out there and can really catch you. And you don't want to be caught with some sort of an environmental problem that you didn't even know existed, or how do you go about and remedy it? That's what we've heard from Jack today. Now, you've also, it's cool, it was also, Jack, you work, I mean, you've done a lot of stuff in your business and your website. Again, it's emcengineerscientists.com. And if you go there, you can see some of the projects and things that you've worked on. And you've got your company is really interesting because you do a lot of different things. It's very impressive, by the way. I've been on there. But you did a project at the port of Brookings after the tsunami. You know, remember when the Japan tsunami in 2011 came clear across and hit Crescent City and Brookings, the two harbors, and did a lot of damage. I didn't see Brookings, but I did see Crescent Cities right after that. But you found solutions again, trying to come up with ways to mitigate these things. So tell folks, because it's a fascinating story about what you ended up doing to make Brookings really a pretty darn safe harbor right now.
Well, okay. Let me try to take credit where it's due and not do it where it isn't due. But when the tsunami hit, the port manager at the time, his name was Ted Fitzgerald, he was out there warning folks that it was coming, trying to get the boats out of the harbor so they wouldn't get damaged. And he was working out there hard. The boy was he had a broken wrist and he was pushing boats when I came in and saw him that morning on March 11th. Of 2011. And coincidentally, he had hired me to come to the port in the previous year to do what's called a bathymetric survey. That is, measure the elevations of the mud line and see how shallow the port was all around the entire port. And so the reason for that was, we're trying to look at future, what they call dredging, which means you take the mud and you remove it.
You move it and do something with it. Okay.
Do something with it.
Is that usually polluted mud when you remove it out from a harbor like that?
Some harbors have polluted mud. Okay. You're required, of course, it takes a year and a half to get the permit sometimes to do this.
You're testing soils.
You're doing testing all sorts soils. Of things. You're testing. You've got what's called SEF, the framework, a sediment evaluation framework, which is laid out a bunch of chemicals and what concentrations are allowed, et cetera. Okay, and they're concerned about aquatic life, and so sometimes they're a lot more severe as far as lower allowables than you find. Okay. So anyway, so I had already been contracted to do that, and I had gotten that done, and that was very fortunate because when the tsunami came, and not only did it do a lot of damage along all the piers. I mean, and
it damaged boats, the piers.
It damaged the boats, the docks themselves, the finger docks. It just took a lot of soil out of there, created some landslides. Had some serious issues there, and they're still dealing with now, and exacerbated by some wetter winters that have caused a lot of loss of soil cohesion and so their failure of slopes. So you see that too. But in this case, we divided into really three main issues to deal with the tsunami damage. As far as the structure of the port itself, one was the docks, and so
the docks themselves. Okay.
So I subcontracted OBEC, which is an engineering firm, and they went ahead and did a little engineering, but mostly brought in a Bellingham Marine to bring in some new docks.
I got to speed you up. What did you end up doing at the end? We're going to run out of time.
You bet.
Okay.
So the dredging part of it was interesting. Is we had to find a way to get the mud out. So I designed a 2-mile long pipeline that went out to an EPA ocean disposal area, and we got a permit to bring it out there.
Wow. Okay.
And so we floated the pipe so that the 33,000 boat crossings that happen a year at Brookings, none of the boats would crash into a pipe if it happened to float. We floated it and lit it so that everybody knew where it was.
Oh, wow.
And so we removed about 30,000 cubic yards of sediment, which is equivalent to about 25 feet high of an acre of material. If you put it an acre
1 acre,
wide,
25 feet high.
25 feet high would be about what we removed. And we removed that in about 30 days.
Jeez.
So that was a good project. We got FEMA assistance, and we also got a state matching funds.
Why, in your opinion, why is the port safer today now after what you've done? Why is it safer now?
Well, it's safer. It's more utilizable, more utilitarian. Everybody can can float their boats and moor their boats without getting them destroyed. And
without fear of a tsunami coming in and doing that again, right?
Well, we have put in larger piles.
Okay.
To protect. We need to have more work to do over there. I'm in the process of doing that.
You're still doing it?
Oh, yes. Still work for
years
the ports.
later. Wow.
And in fact, I work for 7 ports right now.
Wow.
And we do similar things. We're trying to mitigate in terms of the description. What mitigate means different things to different types of bodies of regulation. But in FEMA, for FEMA, mitigation means to make something better than it was before to help ballast against future similar events, disasters that could occur.
Sure.
And they have found when they're willing to pay that, FEMA's willing to pay for that mitigation up to 100% of your original cost for bringing it back to where it was, because they found an 8-to-1 return in doing that. So so there's some savings to the infrastructure of our country by mitigating, that is, making it better than it was.
On the ports that you work at, is Brookings the safest of those ports that you work on?
Hard to say. They all have different challenges.
Each one's different. Yeah, absolutely. Now, you also, before we go out of time, we're going to run out of time, but you can also talk about engineering's solutions to people who want to expand ponds, clean ponds. I mean, there's all sorts of things that you can do. And again, it was when I met Jack, it was like, geez, this is something that so many of us never talk about. But these are problems that come up, and we don't know how to solve them. But yet, what I've learned from you is that there are solutions, and there are good solutions to these things that don't cost you millions of dollars to do.
Right. Keep your head up. Keep your chin up. It's going to be okay.
It'll be okay. Jack, nice to meet you. And again, emcengineerscientist.com is the website. Check it out. That'll do it for the Real Estate Show here for December the 2nd. Have a great week, everybody. We'll talk to you next Saturday when another edition of the Real Estate Show right here on KMED.
You've been listening to The Real Estate Show on KMED Radio, presented by the Rogue Valley Association of Realtors, along with John L. Scott Real Estate of Southern Oregon and Bank 34 Mortgage. For guest contact information, download our free app, or to watch a past show, visit us online at realestateshoworegon.com. This show is produced by Table Rock Productions. Join us again next weekend for Southern Oregon's one and only Real Estate Show on KMED. And thank you for making the Real Estate Show part of your weekend.